Hi, I'm Gavin Guerra,
I'm Jessica Garcia.
I'm Brian Sanchez.
and our topic is nanofiber composites. Today we will give you an overview of what a nanofiber composite is, how it is made, the scientific and engineering bases, the interdisciplinary, multidisciplinary approach, the global, economical, and environmental impacts, and also challenges relating to the use of nanofiber composites. So what is a nanofiber composite? A nanofiber composite is a very thin fiber measured in nanometers. The production methods of nanofiber composites first took place in 1902 by the inventor J.F. Cooley. Nanofiber composites are generally used by engineers who combine multiple nanofibers of different polymers together to get a material called a composite. Nanofibers are created by a process called electrospinning. Electrospinning is the most common method to produce nanofibers. This method includes an electric field, a syringe, an electrode, and a solution. It starts off with an electrode charging the solution of polymers. From here, the solution is squeezed through the needle of the syringe to form a Taylor cone. Finally, once through the cone, the polymer solution jets towards the opposite end of the electric field, drying and becoming what we know as a nanofiber.
The most common use for nanofiber composites occurs within the biomedical field. Magnetic nanofiber composites could act as cardiac patches or artificial nerve guides that can be easily manipulated with an external field. Researchers have also developed nanofibers that have a coat of antibodies that will attach itself to individual cancer cells for analysis. Several universities are currently working on increasing the formation of cartilage within joints through the use of electric nanofiber composites. Others are constructing an elastic material that is embedded with needle-like carbon nanofibers that will pierce the tissue and distribute a therapeutic drug. The image to the right shows a few different examples of how drugs are incorporated in nanofibers. Other fields of science are also taking advantage of the properties exhibited by nanofibers. For example, researchers at MIT and Stanford are using carbon nanofibers to make batteries that have a greater storage capacity. Lastly, scientists have successfully formed piezoelectric nanofibers that have the flexibility to be woven into clothing and can gather mechanical energy from the environment, which is shown in the image below.
Nanofiber composites on an environmental, global, and economical scale can be viewed as a new energy source. This new energy source consists of using electrospun nanofiber membranes in polymer batteries, photovoltaic cells, and polymer electrolyte membrane fuel cells. This is environmental because it is a natural resource that we can use as an energy substitute. Economical because due to the high demand for other energy sources such as oil and coal, we need a new energy source for growing countries. And global because this energy source can be used throughout the world to replace current energy sources. As stated recently by Jessica, nanofiber composites have many different uses, such as new energy uses, healthcare uses, biotechnology, etc. The fact that there are so many different uses is an economical stand because it reaches out to many different fields. For example, using nanofiber technology will be able to benefit an environmental engineer while at the same time benefiting a doctor in new medical procedures. This is also a global stance because this technology or new procedures can be sold worldwide to be implemented in different countries. Although nanofiber composites have many different uses and capabilities, there are still issues that engineers must deal with when dealing with nanofiber composites. This includes problems such as interlayer slippage. As stated by Du, Bai, and Chang, when dealing with composites, one must be aware of the slippage because they will not be able to take full advantage of the mechanical properties. In conclusion, nanofiber composites are made up of polymers. They are produced by electrospinning and can be used for a variety of different applications around the world.